Hello students, we are going to take today's topic circle. In grade 9 also you have learned circle and circle theorems. This year also you are going to learn theorem related to tangent, right? So here first let us see the circle. What is the meaning of a circle? It is a pathway of points. It is the collection of infinite points which are at a fixed distance from a fixed point. That fixed point is O and the fixed distance from center to the circle is called as radius. So here what is the radius? We know radius is nothing but here in this case it is OP, which is represented by small r. Now if you take any 2 points on the circle, if I take point A and B, right, and if I join through these 2 points with a line segment, the line segment joining 2 points on the of the circle, it's known as chord, right? So here the chord AB is a chord. Similarly, if we know the longest chord, if I extend OP to the other side here to the circle, right, it will form a diameter, right? So diameter is also, you are taking 2 points on the circle here, PQ. So PQ is a diameter. Diameter is PQ, which is known as the longest chord. Right, all these basics you have learned in your lower grades also. This is the longest chord. Correct. Now, what is the meaning of arc? If I take a piece of circle, right here, if I take AB, right, this is a piece of a circle. Or if I take PQ, this is also a piece of a circle. This is called an arc because it's a piece of circle. So, what is the meaning of arc here? This is called arc. This is AB arc, and this is nothing but minor arc, right? So arc can be written as minor and major based on whether you are taking the smaller piece of circle or bigger piece of circle. Now if I take one point here x, if I take here the length AXB, this is the arc length, right? So because it is more than semicircle, this is known as major arc. So AXB, this is your major arc, right? Other than this, you should know what is the meaning of segment, what is the meaning of sector. So yeah, and because we have taken minor arc, so this is called as minor segment, right? So here this is AB here. If I can write down here AXB, and if I take another point here, so this is your minor segment. So here segment is the area between a chord and the chord and the minor arc. Okay, then similarly here, if this is your y, and if I take here major arc, the area enclosed between the major arc and the chord is known as here major segment. So here in major segment and sector, we are talking about the area, okay, within the circle. Now, other than that, what is the meaning of sector here? If I am taking a circle, right, and if I take center O, the area enclosed between two radii, so here P and Q are radii, right, OP and OQ are radii, and PQ is an arc. So what is the area enclosed between these two radii and this arc? That's known as sector, because again here, because it was your minor arc, so we call it as minor sector. Minor sector. Similarly, the area enclosed between the major arc. Here, if you'll see, PQ is the major arc, right? So, area between major arc and two radii. So, if I take here, shade it here, this is always more than semicircle. So, this is known as major sector, right? Other than that, what is, sometime you must have heard about semicircle. So if what is the meaning of semicircle? So if I take a circle, you get semicircle when the circle is divided by a diameter. If I take this is OAB is a diameter. So here if I'm talking about this is the area enclosed between, right? Both sides there are equal arcs, whether you take above or below, right? So this is known as semicircle. Semicircle. right? So these are the basics. Other than that, you are going to learn here tangent theorem, right? So before we take tangent theorem, theorem based on tangent of circle, first you should know what is the meaning of a tangent. So if I am talking about a tangent, tangent is a line segment, or it's a line. It is a line touches circle at only one point. What does this mean? If you draw the figure, you will understand what is the meaning of tangent. So let us draw a circle here. If I am taking a circle, right? A circle is a collection of infinite points, and this is center O. Now, if I take any point A on circle, now a line touching a circle at A, there will be only one possibility, right? See here, this is a line. If I write down here, this is a line XY touching circle at A, right? So here we can write down XY touching circle at A, right? Similarly, if you take any other point, here if I take it as B, how the tangent can be drawn. So you should know here we have written what is the condition. The tangent should touch the circle at one point only, right? So here if I see, right, let us see, it is touching circle at B. So this place is here, this point is called B, point B, which is the point of contact, right? So here if I name this as XY, here if I name it as PQ, right? So line PQ is touching circle at B. So PQ touching circle at B. So here you will see A and B are called as point of contact. Okay, point of contact, right? And what do we call here? This is the first pointer. What is the second pointer here? XY and AB, PQ, as per our definition. Okay, XY and PQ are tangents or to the circle. So how many tangents can be drawn to the circle? If you'll see, there are infinite points. Any and every line will, through every point on the circle you can draw a tangent. So there can be infinite tangents drawn on the circle at every one point. Now can we draw, then the question arises, can we draw two tangents at one point? Let us see if we can do that. So here if I take a circle, okay, the center is O. If I'm taking here point A, right? Now let us try to draw a tangent. So first if I'll try to draw one tangent passing through A, if you will see, now see here, it can touch circle at one point. At A, there is only one possibility, right here. This one we can't do it because we have seen if you are moving like this, your tangent is touching circle at two places. So let us move it here. Now let me try to draw all the other points. If you will see, all the other lines through this point will touch the circle at two places, right? Look at here, this is A, this is B, right? If I try to draw line like this, then it is touching circle at C, at two places, AC. So there can be only one tangent at a point, right? So here, what can we write down here? Tangent becomes secant when the line touches line, cut or touching, cut, circle at 2 points, right? Now here you can see that as example, AC and AB are the secant, right? So here AB and AC are secant. So these are the basics. You should know what is the meaning of tangent of a circle and what is the meaning of secant of a circle. And this is the first theorem of circles. So let us see how are we going to see that, how are you going to prove the tangent of any point on the circle of a circle is perpendicular to the radius through the point of contact. So first let us draw a circle. So if I draw a circle here, right here, if I take center, and if I draw a tangent xy, let us draw a tangent xy here, which is touching circle at point P, right? What do I need to prove here? If I join O to P, this should be the shortest distance, right? So what do I need to prove here? It is to prove is OP is perpendicular to xy at P, right? What is the meaning of perpendicular? So I have to prove that O to OP is the shortest distance from O to tangent xy. How are we going to prove it here? Let us take, we are going to prove this using contradiction, right? Let us take another point, right, which must lie outside the circle. Why we cannot take it inside the circle here? Right, see here. Now you know that OP is the radius. OP is radius. Correct? Now OQQ must lie outside the circle, right? Outside the circle. Otherwise, what will happen if I'm taking any point here inside the circle? If Q is inside, that means the length is going to be less than radius, then your tangent will become a secant, right? So we can't take it. We are going otherwise PQXY will be a secant. Right, now you know that this is not the radius, this is on the exterior. So can I write down here OQ is less than is going to be greater than OP. Similarly, if I take all the points on XY, right, it is going to be the OQ length is greater than OP. Similarly, here any point on this line OQ, the distance from O is going to be greater than OP. So you can write down here similarly all the points, or there are infinite points on the tangent, okay, all the points on the tangent distance, tangent's distance from center is greater than OP, right? Now the moment if I say all the other distance is greater than OP, can we say that then OP is the shortest distance? It is the shortest distance from O to XY, right? Therefore, and you know that the shortest distance is always perpendicular. Hence, OP is going to be perpendicular to XY at P. That is why we say that the tangent is perpendicular to the radius of the circle at point of contact. You need to prove the point of contact, right? You need to remember this theorem because when you are solving the question, you must write down this reasoning. Now, what is your second theorem? There is one more theorem that you use to solve the circle questions. Right here, this is again, first you have seen a tangent to a circle, right? Now, they are talking about the length of the tangent drawn from an exterior point of the circle are equal in length, right? How are you going to disprove also? Sometime it comes. So you should know how are you going to prove this, right? So if I take a circle, now this is center. The external point, any external point is always going to be on the exterior of the circle. So take a point here P, right? P is an external point, and if you draw two tangents, there is only two tangents possible to be drawn from an exterior point. So what are those two tangents? If I take here, PA is touching circle at A and PB is another tangent touching circle at B. Okay, so here what can I write on here? What is given? A circle with center O, with center O, then PA and PB are two tangents drawn from an external point P, right? This part is only given. Now what do I need to prove here? You need to prove that the length of these two tangents are always equal. So PA is equals to PB. You are going to prove it, right? How are you going to prove here? Before trying to prove here, we are going to prove these two. You have to do some construction, because all the proving most of the time in circle we use congruency. And now if you need congruency of triangles, you should have the triangle. So first thing, you are going to join OA, OB, right? So here you can write down here, join OA, OB, and to get the triangle I am going to draw OP also. Now can you see here, there are two triangles. If I can prove that these two triangles are congruent, then automatically PA will be equals to PB by using CPCT, because corresponding parts of congruent triangles are always equal. Okay, so here let us take here proof. How are you going to take the proving part? So first thing, consider the triangle. In triangle AOP and triangle BOP. Now before we start writing, let us see here. First, you know that we can use the first theorem, radius and tangents are perpendicular. So can you see this is 90-degree angle in both the triangle. Then always the radii are always equal and this is the common side, right? OP is the common side. So using RHS, you can see that here right angle, hypotenuse and the side will be equals to right angle, hypotenuse and side, right? So how are you going to take it here? Let us see. So this is RHS congruency. So if I am taking this, first thing, let us take the part of the first triangle. Okay, let me take this figure so I can refer it to prove the congruency. Here, this is your figure. So what is the first one? Right angle. Please remember, in congruency you have to write down the correct correspondence. So angle OAP is equals to angle OBP. Why? Because because you did not write down the reason in the given. So you must write down here, tangent is perpendicular to the radius, perpendicular to the radius through point of contact, right? So this reason you have to write down. Then hypotenuse is the common side opposite to 90 degrees always hypotenuse. So OP is equals to OP, and the reason you can write down here, common side. And then the side here, if I say OA is equals to OP, because radii of same circle are always going to be equal. Now using which congruence criteria we can write down here? Using RHS congruence criteria, we can say that triangle AOP or OAP, we have written here AOP, so let us take AOP only. AOP is congruent to triangle BOP, right? The moment you prove these two triangles are congruent, automatically the corresponding sides, which is PA or AP, is equals to BP, or we have written here to prove PA. So I can take here PA is equals to PB by CPCT. So PA, therefore PA equals to PB, and you are using corresponding parts of congruent triangles are always equal. Now you have proved that the tangents drawn from an exterior point are always equal in length. Right? Now why this is first, these two theorems are very important because you use these two theorems sometime to solve the questions as well, right? Other than this, you all have to remember the Pythagoras theorem also, because sometime in MCQ based question, the questions are going to be based on Pythagoras theorem. So let us see here. If I am giving you one question here first, which is MCQ type question. If I am giving you here, there is a circle, okay, and the tangent PQ, which is touching circle at P, and the length of tangent is PQ, right? If I add the distance of O to P, it is given as here 3 centimeter. The distance of O from the center, O to Q, which is Q from the center, if it is 5 centimeter, you need to find out the length PQ, the length of the tangent. How are you going to find out? Now the first theorem you have to remember, the tangent is always perpendicular to the radius. So you must know that this is perpendicular. So what are those two sides? OP is perpendicular to this tangent, right? The moment you get right triangle, you can use Pythagoras theorem. So OQ square equals to OP square plus PQ square, right? So 5 square equals to 3 square plus PQ square. Using Pythagoras theorem, we can find out the length of the tangent. Right, this is 16 square root of 16, and PQ length is going to be 4 centimeter. Right? So most of the time in MCQ, you are going to use Pythagoras theorem to find out, you can calculate radius, you can find out the exterior point distance from center O, or the length of tangent, right? Now how do you will get sometime the proving based question also. So let us see here first proving based question here. What is given here? Prove that the tangents drawn at the end of the diameter of the circle are parallel, right? So first let us, every time when the figures are not given, figure is not given, you'll get half to 1 mark to draw the figure. This is a 2 marker question, so there will be only half mark of drawing the right figure. So first thing, take a circle with center O. Now what is written here? Prove that the tangents drawn at the end of diameter. So I have to draw the diameter. Here if I am taking the diameter vertically, which is passing through center. So AB is a diameter, right? Now I have to draw the two tangents because the point of contact is A and B. So let us draw two tangent here. Now PQ is a tangent, and PR is also another tangent, right? So if I write down here PQ and this is RS, I have to prove that these two of them are always parallel. So first you start with what is given. Given is a circle with center O. Any proving question given to prove for any construction which is required, with center O and diameter AB. What else is given here? PQ and RS are the tangents, right? This is given at A and B. Now what you need to prove it here? You need to prove that these two, because they are drawn at the end of the diameter, so PQ is parallel to RS. Now how do we prove two lines are parallel? If I can prove that any one property, which is alternate interior angles are equal, or corresponding angles are equal, or co-interior angles are supplementary, if I can prove any of these property, then I can prove that the lines are parallel. Now, before we take that, what am I going to do it? You can see that OB is perpendicular to RS, right? So here, what can I write down here? OB is perpendicular to RS. Similarly, OA is going to be perpendicular to PQ. What is the reason here? Tangent is the reasoning you have to mention the reason. Okay, tangent is perpendicular to the radius of the circle through point of contact. Through point of contact. Right, so here what are the point of contacts? A and B. So because this is true, can I write down here, if I'm writing this, can I write down here angle, this is perpendicular, right? So angle OBS equals to angle OBR equals to 90 degree. Similarly, angle OAP equals to angle OAQ is equals to 90 degree, because this is perpendicular, radius is perpendicular to the tangent. Now either you take alternate interior angles are equal or co-interior angles are supplementary. So you need to mention that angle OBS is equals to angle OAP, then equal, they both are 90 degree. Since alternate interior angles are equal, therefore your PQ is going to be parallel to RS, hence proved. You have proved that the tangents drawn at the end of the diameter are always parallel, right? I hope you got it. Thank you. Have a good day.
Thank you for watching this video. Please like, share and subscribe. Also, keep practicing.